will learn about line graph. Sometimes data also changes with time. For example, the number of students in the class may change on different days. Such data can be presented by a line graph. Similarly, the distance traveled by car at different times can also be changed, which can be presented as a line graph. A fruit seller's earning for each day of week can also be changed, which we can represent as follows. A line graph is shown here. Can you tell me what information it gives? Think. This line graph gives us information about the sales made by a watch manufacturer every month. You can see that the sales of watches in various months are shown with different points which have been joined by line segments. Similarly, in graphs, data is represented by points which are linked by line segments. The figure shown tells us that different watches have been sold here in different months. Similarly, the line graph shows the change in statistics over time. This shows us the pattern of data. Like here, we see that sales have decreased from January to March, whereas after March, the sales have increased. Similarly, among all the months shown, the least number of watches are sold in March. Let us learn to draw a line graph with an example. A car travels 250 kilometers from its starting position A to position B. The distance of the car from place A at different times is shown in this table. Now, represent this data on the graph. We will take a graph paper. On this, horizontal line will be drawn, which is called x-axis. We will show the time on x-axis. Similarly, we will draw a vertical line, which is also called y-axis. On this, we will mark the distance of the car from position A. To show this distance, we will take 1 unit is equal to 50 km scale on the vertical line. Now, we will mark the data by points. At 12 o'clock, the distance of the car from position A is 0 km. So, we will mark the point at intersection of the vertical line at 12 o'clock and the horizontal line representing 0 km at 12 o'clock. Similarly, at 1 o'clock in the afternoon, the distance of the car from position A is 50 km. So, we will mark the point at the intersection of the y-axis and 1 o'clock in the afternoon at the horizontal line representing 50 km. Similarly, we will mark all the data given in the table. Now, we will connect these points with the line segments. From this, we will get a graph of the distance of car from place A at different times. With the help of this line graph, we can now tell the position of the car at given time. With the help of line graphs, two groups of data can be easily compared, which we will understand with some examples in the next video. Today we have learned about line graph. In the next video, we will learn interesting examples related to this. Today we will see some interesting examples on line graph. Look at the line graph shown. What information is displayed in this graph? The graph shows the months on the horizontal axis and the number of motorcycles sold on the vertical axis. In this way, the continuous line shows the number of motorcycles sold in different months of the year 2007 and the dotted line shows the number of motorcycles sold in the various months of the year 2008. The graph shown in this way compares the number of motorcycles sold in various months of the year 2007 and the year 2008. How many more motorcycles were sold in March 2008 as compared to March 2007? It is observed from the graph shown that 120 motorcycles were sold in March 2008 and 60 motorcycles were sold in March 2007. The difference between the two numbers is 120 minus 60 is equal to 60. So, we can say that in March 2008, 60 more motorcycles were sold than in March 2007. Find the month from both years in which the number of motorcycles are sold equally. In the graph, the continuous line and the dotted line intersect at a point. The intersection point is located in April month. This tells us that in both years, the number of motorcycles sold in the month of April is equal. Let's see the next example. Ramesh planted a plant. At the end of each week, he found the length of the plant, which was as follows. Consider scale as 1 unit is equal to 2 cm. Represent the given information in a line graph. A line graph represents data that changes continuously over time. Data is displayed by dots in the line graph. Now, let us draw a graph based on the information shown. Draw two mutually perpendicular lines on the paper. The horizontal line is the x-axis and vertical line is the y-axis. We will show the time in the week on the x-axis. Similarly, we will show the length of the plant on the y-axis by taking a scale of 1 unit is equal to 2 cm. As the maximum value here is 11 cm, we will end the length on the y-axis by a greater number such as 12 cm. Now, we will mark the data by point. Initially, that is, plant length is 0 in 0 position. Therefore, we will mark the point at 0. Similarly, the length of plant in week 1 is 2 cm. To denote this length, we will mark the points at the intersection of the vertical line of week 1 and the horizontal line of 2 cm. Similarly, the length of plant in week 2 is 7 cm. To denote this length, we will mark the points at the intersection of the vertical line of week 2 and the horizontal line 7 cm. Similarly, we will mark the point for all observations. Now we will connect all the points with line segments. We have shown an increase in plant length over time as a graph. Therefore, we can call it a graph of time growth. Today we have seen some interesting examples on line graph. In the next video, we will see some more examples. Today we will see an example on line graph. Which of the following graphs shown below are possible between time and distance? In the first line graph, distance is also increasing with time. Is this possible between time and distance? Think. Absolutely right. It is possible that distance increase with time. For example, the distance from the start of a vehicle's journey increases over time. The distance traveled by a rocket also increases with time. Therefore, we can say that line graph 1 can be a time-distance graph. Line graph 2 shows a situation in which time is increasing but the distance is the same. Is such a situation possible? Think. Let me tell you, yes, such a situation is possible. If during the journey, the car stops somewhere before reaching the last place. So, in such a situation, time will increase but distance traveled will remain the same. Hence, line graph 2 can be a distance time graph. The distance is decreasing with time in the situation shown in the line graph 3. While returning from a starting place, the time increases, but distance from starting place will decrease. Therefore, the situation shown in the line graph 3 is possible. Therefore, line graph 3 can be time distance graph. Now, can you tell me that line graph 4 shows which position? In the line graph 4, distance is increasing but time is constant. This is not possible. Therefore, there cannot be such a graph between time and distance. So today we have seen another interesting example related to line graph.